final circle. Okay, so this is 50, so 250. So in your exam, when you solve this problem, you have to draw all these, okay? You have to draw all the 3 circles. Okay, so this is for your X, Z plane. Okay. Now, some of you say, is there another possibility? Yes, there's another combination. Okay, but that combination will not work. Okay, and I'll show you one more combination. Okay, so remember when we started, before I go on, anyone, any questions, please? Anyone want me to repeat which part you don't understand?
Yeah, I have a quick question. So earlier you said that the big circle we drew, the biggest one, that's the YZ plane, right? But
yes.
But normally whenever we've drawn like the YZ plane, that would be in between the line of the Y stress and the line of the Z stress. Here it's bigger than the line of the Y stress.
Yes.
Can you just explain why that is?
There's no rules. You cannot restrict, like it only can be there and not in another place. You're putting in a rule that is not necessarily true. Mustafa?
Okay.
Okay, you cannot just put the rule there and this circle has to be in this. No. Okay, it's all controlled by the position of the stress state of the element or the cube or the element, the 3D element. Okay.
Okay, thank you.
Okay. Anyone, any other question?
I have a question.
Oh no, yes.
It's a simple geometry question. You know how you drew the first alpha?
Okay.
How did you get the alpha with the double rings? Why is that alpha?
Okay, so let me go back to this. Ooh, I thought I'm going to die again. Okay, so look, watch here. Right? So if this is alpha, this is also equal to alpha because both of them share the same radius.
No.
So over here is 180 minus 2 alpha. Angle of a straight line, this is 2 alpha. Does that make sense now?
Yeah, no, that one makes sense. I have a different question.
Okay.
Like, you know the alpha between the orange line?
This one over here?
The vertical orange line? Yeah, that one. Both of them. How did you know both of those were alpha?
So, it's going to look so ugly now. Similar triangles. This triangle and this triangle, the angles are the same. Is this two we are talking about? Yes?
Yeah.
Yeah, so that's why if this is alpha, this is also alpha. If you're not happy about it, can you like draw it and then measure it with a protractor?
Yeah, I'll do that.
Okay. I'm not lying, you cheeky sod. Okay? Okay. Right. Now there's another
I had
I
had a quick question. Like trying to draw this by hand, like isn't there like a lot of room for error? Because I know for 2D more circle, like everything had to line up. So I'm a little worried about like the 3D one. Like how will marks be awarded if like we mess up like just the proportions or whatever drawing by hand?
You can see, like I still calculate the values, right? I don't rely on the mole circle to determine the value. I look at the mole circle to help me do the calculation.
Oh, I see. Okay.
Yeah, Ash, relax, have the chill pill, Ash.
Okay, thank you.
Okay, if you're off by 0.1, the TA will take away 0.1. You think that? No, come on, okay? Right. So there's another possibility. And there's another possibility, right? Which the textbook or the answer from here they don't show, okay? Right? They take it for granted. Oh, where is it? Hey, where was I? Oh, here. Okay. So they don't show, they take it for granted. The solution manual say, okay, this is it, and go for it, have fun. Okay. Well, we don't do that, okay? So there's another possibility. Right? So how we drew this small circle is we let we let this line that I'm going to highlight in blue, right? Right, we drew this line first. Right, then everything evolves. Okay, everything. Now that's another possibility. Okay, and I'm going to not start from mean to x, but I'm going to go to z. Okay, so we're going to draw this line. Okay, now we're going to do this. And I'll do this very quickly. I won't calculate. Okay, I'll repeat. I'll do this very quickly. I won't calculate because I have more examples to show you guys. Or the shear failure. The shear is going to be real good. Okay, so normal stress, shear stress, minus 20, minus 40, minus 60, minus 80, clockwise, anti-clockwise, 20, 40, 60, 80, 0, and 20, minus 20, minus 40, minus 60, minus 80, 100, 120, 140, 160. Then I'll draw the no man's land again. Okay. Yeah, so this is one line. This the other line at 75. Okay, so we know that point Z is here, right? And then we are going to draw another line down here, a minus 70 line. And then we have our 40, 40. Right? We have a 40, 40. So another possibility is this is our point X, right? This is our point Z. We let it join. Right? Right? It's a possible value, right? Then we draw another circle. Or then from here we apply rules of the circle, right? We apply rules of, so copy and then paste. Then I rotate this by 90 degrees. Right? All right. So this is another possibility, right? So over here, so now if I go calculate alpha again, right? So this is our alpha over here. So let me do the calculation quickly. So tangent alpha is still the same, right? Alpha is still the same like before. It's 26.57. Okay, 26.57. Right? So then we are going to take minus 70. Okay, or I'm going to call this our stress A. So stress A is equal to minus 70 minus, right? So tangent alpha, so alpha is the same. So tangent 26.57. Okay, but so that value is 40, right? So minus 70 minus by tangent 26.57 times 40 is also minus 20. Okay, so now this is equal to minus 90. Okay, so where it intersect is minus 90. Okay. So when it's minus 90, right? Right, it's minus 90. So minus 90 means the center of the circle is minus 45. Okay, so this is our minus 45 line. Right, so this is our minus 45 line. Okay, so from here, we can draw another line. Right, cut straight across the center of the circle, minus 45, and we reach the other circle, or we reach the other point. Now this value now is our y2. Okay, so now I can draw another circle. Okay, so is 45. Right. Okay, so this is our the other circle. Okay, now what you realize over here now, okay, I did not construct it properly, my fault, okay. So what you realize now, there's another possible value. Okay, the other possible value is y2 is equal to what? So y2 has a certain value. So I'm just going to eyeball this. So I will say approximately equal to minus 20 megapascal. Right? Now, why is this answer not valid? Anyone? Right? It's still within the operating bracket. But why is it wrong? Anyone, please? Hello. Now, listen. It is possible to have 3D mole circle. I repeat again. It's possible to have 3D mole circle, just one circle. This is the case. I repeat again. It is possible for 3D mole circle analysis just to have one circle. And this is the case. But why is this answer not valid? I think it's no good to ask a question like that on a Friday afternoon. Okay. The reason why is because what? They not satisfy the criteria of tau max must be equal to 75 megapascal. You all can see that, right? So this is the only circle that you need to draw, okay? Because all 3 points, x, y, 2, and z are all on one circle. And this is also a 3D mole circle, okay? Right? So that's why this answer is what? Okay, it's not valid. Because if you look at the question specifies that is what? Okay, for which the maximum shear stress must be 75. So for this case, it satisfies the 75, and the 75 is on YZ plane. Okay, and the one that we did today, okay, the 75 is in your what? XY plane. And it's for that reason the third option is not possible. Okay, that's the reason that the third option is not possible. Are we clear? Okay, because some of you might think, hey, Eugene, I can start by connecting. So the original analysis or construction is you draw this line first. Okay, then you start drawing the circle. Whereas the solution before or this one, we draw what? We draw this line first. Yes or no? That's how we construct our 3D mole circle. Okay. Hey, I did not say that this is wrong. It's possible to have a 3D mole circle analysis to be one circle. I just show you that. Anyone, any questions?
Yeah, I have another question, sorry.
Yes.
Can we go back to scroll up to the previous the solution right here? I'm just still a little bit confused about that bigger circle. So let's say the question gave us y2, like it gave us y2 and x and z, and we had to draw the more circle. I just don't get how we'd arrive at that biggest circle.
It's controlled by maximum minimum stress.
Oh, so we would draw the xy one first.
So this is the biggest circle is controlled by the stress minimum. Right? So you have this, you have your x first, and then you have your stress minimum, yes or no?
Yeah, I'm saying, let's say the question gave it to us the other way around. Like we were given, so the question said y is negative 130. It gave us x and it gave us z is 0. So the question gave us that and just told us to draw the circles. How would we go about doing that?
So y is equal to what? Minus 130.
Yeah, we were told that. Let's say we were told that. And we had to draw what you drew. How would we get there?
And then this is equal to 0.
And x is still 70. Or negative 70.
Net x is equal to minus 70.
Yeah.
Okay. So this is minus 130, 0, minus 70. The shear still there, right?
Yeah.
point X, point Y, point Z. Okay, I try to construct as accurately as possible. So